right, we've got here graphs A and B below were obtained for the volume of oxygen produced over time under different conditions. So there you go. You've got volume, you've got time, and different conditions because you've got graph A and graph B. Calculate the average rate of the reaction in decimeter cubed per second between T 10 seconds and 40 seconds for graph A. Be careful. So you concentrate on this graph here. So if we talk about graph A, and then you have your 10 seconds, where do we have 10? So 10 is somewhere there. And you go straight up to that A there. And then you go for T, which is equal to 40 seconds. T is 40 seconds. So this might go somewhere up there, 40 seconds. For A, don't forget that. So it's this and somewhere there, okay? So you are going to look for delta Y, which is Y2 minus Y1 over X2 minus X1. And when you do that, you will definitely come to an answer which is very close to 1,2 decimeter cubed per second. Okay, when you look at those values there, if maybe we have to estimate, this here can be taken as 52, and the other one can be about 16, and obviously the times I can't just guess because they were already given. We have 40 minus 10, so that's why I'm saying that ultimately you are going to have your answer is that. But remember, you've got to put those units per second. Okay, so the main thing is to know how to do that because we are talking about the rate. So it is something over time. So whatever we have there, over time. Use the information in graph A to calculate the mass of hydrogen peroxide used in the reaction. Assume that all the hydrogen peroxide decomposed use 24 cubic decimeter per mole as the molar volume of oxygen. So this is important. We need to make use of that. And then you need to know what the hydrogen peroxide was, how much of that decomposed. And the only way out is by using this information here. Right, so the first thing that we'll do is to go back to what we have just found here, and that was the average. And is there any other information that was given? Not yet. Okay, so what we are going to do, we will use this volume, and then we use, when you go to your information sheet, you will find that, you know, you've got a certain formula, N, and then you've got V, and then Vm. So this Vm is the molar volume. Can you see that? So that is what you are going to use.